So an ARMA PQ model is one where you have an ARMA P on one side and an MAQ on the other side. What do we mean by that? So you have YT plus V1 YT minus 1, V2 YT minus 2, VB YT minus B, the left hand side. And on the right hand side, we will have epsilon t, theta 1 epsilon t minus 1, theta 2 epsilon t minus 3, theta cubed epsilon t minus. Well, epsilon is the standard white noise stuff, isn't it? If I wrote in terms of the backwards operator, I have phi1b yt, phi2b squared yt, phi b raised p yt. On the other side, epsilon t plus theta 1b epsilon t plus theta 2b squared epsilon t, theta cubed b raised q epsilon t. This is something that should look familiar to you because previously we looked at AR model and MA model separately. So if it is an ARP, we didn't have any of those. We ended up with that. If it was an MAQ, we did not have any of this. We simply had that. Now it is a combination of both AR and MA. YT is in common. And that's what I would have in terms of backwards operator. And on the right hand side, you have 1 plus theta 1b plus theta 2b squared. Theta q times b raised q. What is that called? It has character to it. Characteristic polynomial. So on this side, it is uppercase A of B. On the other side is uppercase theta of B. Of course, it's the same if we rewrote it in terms of the letter rather than the backwards operator. I could say phi of z equals epsilon t theta of z. One and the same. The one on the right we write in terms of the operator b. One on the left is just a variable z. So there are two things that I could do. If I divide both sides by theta of b or theta of z, I'll end up getting that. Do you agree? Which is the same as saying phi of z divided by theta of z. I'll just keep it in terms of backwards operator for now. I can write that ratio as yc multiplied by uppercase I of b. And what did we just do? Yes. So when I apply, so this uppercase pi is going to be a least degree polynomial. Right? So you would have 1 plus b squared all the way up to b raised b, which would imply here you would have yc minus 1, yc minus 2, all the way up to yc minus b. But if it was just phi, true, but I had phi divided by theta, and I ended up getting uppercase pi of b. That's not a p-degree polynomial. I'm sorry. That is an infinite series.
So it's not a p-degree?
No, it's an infinite series. My bad. So phi of b is a p-degree polynomial. Theta of b is a q-degree polynomial. So I took epsilon t. Now I'm writing it as infinite series multiplied by yt. Infinite series, in the sense you have 1, b squared, b cubed, b raised 4, b raised 5, keeps on going. So what did I just do? I wrote the ARMA series in a different form. What series do I have? AR. This is an AR infinity series. Case 2. Instead of dividing by theta b on both sides, if I divide by phi of b on both sides, we have our standard notation. Epsilon c multiplied by psi of b. Psi of b, once again, is an infinite series in terms of the Lag operator. And I'm applying that infinite series to the noise. So what series would we have here? MA. This is an MA infinity series. So that is the general ARMA PQ construct, where we can write an ARMA model in terms of AR infinity, or MA model, or in terms of MA infinity. And we know from last time how to find some of the coefficients of an AR infinity series. Yes, phi1, phi2, phi3. And we did the same with the size, psi1, psi2, psi3. So we can find the highways and sideways easily for any ARMA